Okay, so last lesson of the unit is the problem solving. And so we're going to dive right into it. So there's two main types of problems we'll be doing. One's involving distance, speed, and time. And the other ones, we called them like shared work problems. So first things first, with the distance, speed, and time. In math and in physics, they don't want you using this triangle. So we're going to scribble that out. But next to it, you can write D is equal to RT. So that's distance is equal to the rate or speed multiplied by the time. Okay? So everything that we do in these types of problems, we're going to be using this. Okay? So for example, if I wanted to find what the speed of something was, we just use simple algebra to be like, oh, if we need the rate or the speed, we divide everything by t and get that the rate is equal to the distance over the time. Okay? So let's dive right into example number 1. It's just like the swimming pool. Okay, so we have Shannon cycling for 120 kilometers and swimming for 12 kilometers. And they even gave us this nice little chart. So let's fill this chart out. So we say they're biking for 120 kilometers and swimming for 12 kilometers. It's a lot of biking too. So the average cycling speed is 8 times faster than the average swimming speed. So I'm going to just quickly go like this. And I'm going to scratch out this S and put X. Because S's, they have S for speed, but lots of people think speed, if it's an S, also stands for seconds, and they can sometimes look like 5s. So we're just going to turn it to X and make all of our lives a little bit easier. Okay? So if the cycling speed is 8 times faster than the swimming speed, and the swimming speed is X, how can we represent the cycling speed, Josh? You got it. Okay, it is. Okay, and then we don't know how long was spent swimming and cycling, but we know that together it was 9 hours total. Okay, so there's a couple different steps to solving these problems. So the first step is come up with your simple formula. So what they're asking us to do is they're asking us to calculate the average swimming speed. And so we don't know a whole lot about what's going on here, but one thing we do know is that the total time is 9 hours. So we know that the time of the cycling plus the time of the swim is equal to 9 hours. Right? That makes sense to everyone, right? 9 hours total. We're both biking and swimming. So that those added together should equal 9 hours. And then we say, well, we know that distance is equal to rate times time. And so if we want to put this in terms of time, we know that time is equal to distance over rate. So we'll go distance over rate for cycling plus the distance over rate for swimming is equal to 9 hours. Okay, so all we're doing is we know that distance over rate is equal to time, so we're subbing that right in for time. We'll even put a C here and an S here for cycling and swimming. Okay, and then if we look at our chart up here, we can say, well, we know what our distance and our rate or our speed are for cycling and swimming. So we can go, well, the distance for cycling was 120 and the speed was 8x plus 12 and the distance was x. And if we add them together, we know that it equals 9. Okay? And then so at this point, we just have a pretty simple rational equation now. So the hard part of the question is this part here, coming up with that equation and subbing things in. Once you get to this point, it's pretty smooth sailing. So we just look at it and we say, well, we know that our lowest common denominator, so our LCD, is 8x. And then we can solve it just like we have all of our other problems. Just like that. Okay. And then we can go, well, these cancel out, these cancel out. So we get 120 plus 96 is equal to 72x. Okay. And it's not a quadratic one, so we know that we want to keep the x separate from everything else. So we get 216 is equal to 72x. So x is equal to 3. Okay, so if we look back at our chart and we say, okay, well, x represented the speed of the swimming. So the swim speed is 3 kilometers per hour. And then how would we find the cycling speed as well? Exactly, cycling speed is 8 times 3 to 24 kilometers per hour. Okay, so the actual solving of the equations isn't too bad for this section. If you could write the quizzes that we wrote today and yesterday, you shouldn't have too many problems with it. It's this stuff here, those first two steps where you come up with the simple formula, and then you come up with the more complex formula. So I'd say this one here is our simple one. And then you substitute it to come up with a more complicated one. And then you just get to solve it. Okay? So once you come up with this formula here, it's not too bad. Okay, so we'll go and do the next example. Oh, perfect. Thank you for reminding me. So now that we know our speeds, we can fill in the time part on the chart. So we'll go, so we know that time is distance over speed. So we can go 120 over 24. So how about someone with a calculator? Here's that out. 5. So we know that 5 hours cycling and then 4 hours swimming. 12 divided by 3, or you could also go, well, it's 9 hours total. 9 subtracted by 5 is 4. I think they would tell us in the question. Pardon? Yeah. Okay, so example number 2 now. So right at the top, I'm going to write D is equal to RT, since that's so important. Okay, so the question says, these questions are a little bit wordy, so sometimes you have to kind of fight through the question to get the actual thing you need. So they say, the student council is traveling and their budget allows for 2 different options. They can leave by bus, or they can save 3 hours and use the train, which travels 25 kilometers per hour faster. If the distance between the 2 towns is 1,500 kilometers, determine how long it takes to travel by express train. So, what is our question asking us? So they're saying, how long would it take to travel by express train? 3 hours longer than by bus. So we could say that the time for the bus minus the time for the train is equal to 3, right? Because that's the difference between the length of the two trips. Okay? And then we know from our equation up here that t is equal to distance over rate. So we go distance over rate of the bus minus distance over rate of the train. We do know that the train travels 25 kilometers per hour faster, but that's all we know. Okay? So let's deal with the distance first, because that's the easy part. So for the distance, they both travel the same, and it's 1,500 kilometers. Okay? But then our rate or speed is kind of trickier. So we know the train travels 25 kilometers per hour faster. So if we say that the bus is R, we can say that the train is R plus 25. Okay? So this time we add 25 because they say it's that much faster. If I said I had $2 more than you, and you had $5, you would know I had $7, right? With the previous question, they said 8 times faster. Just like if you had $5 and I said I have 2 times as much money as you would know I had 10, not 7, right? So we know this is equal to 3. So we're done the hard part of the question. This part here is the hard part. Now we just have to solve our rational equation. And so we know for our common denominator, we solve it just like we've been doing. So we say, okay, we know we need an R, and we know we need an R plus 25. And so I usually think of these denominators as being in almost like their own set of brackets. So you can't pull just this R out. You have to take it as a package. So we know it's going to be R multiplied by R plus 25. Okay? And I would just leave it in factored form for now. Okay? And then we get to multiply all of our numerators by it. Just like that. Okay? And before we start doing anything, we'll want to cancel out all the things that we can. And now we're going to start actually simplifying it. So we know that our 1,500 has to go here and here. Let's go together. And I would FOIL these first and then distribute the 3 on that end. So we get 1,500R plus 37,500 minus 1,500R, R squared is 25R. Okay, so I'm going to simplify everything that's on the left, and then on the right, I'm just going to distribute this 3. Okay, so we have 1,500R minus 1,500R, so those cancel out so nicely. Exactly. And then on the other side, we get 3R squared plus 75R. Okay? And so the difference with this question is that in this one, we do have a quadratic, because we have that R squared. So we want to make everything equal to 0. So I'm going to subtract this from both sides. So before we do that, what's something else we should maybe look for? You got it. So GCF of 3, so we get r squared plus 25r minus 1,000 or 12,500. Okay, so now we just have to find two things that add to 25 and multiply to 12,500. So you could graph it, or use the quadratic formula. Okay, so if you graph it, we do find that our two factors are r plus 125 and r minus 100. And then so your x-intercepts would give you get negative 125 and positive 100. So the hardest part about doing that would be coming up with your windows so you could actually see that. Yeah, exactly. So Kelsey says you can't have a negative speed, and she's absolutely right. So even though we have two answers, we know that r has to be greater than 0. So we can completely disregard one of them. So we know that the speed of our bus, because right here, if you look, our bus, the speed is r, and on our train, or what is it? Yeah, and then on the train, it's r25. So the bus speed is 100 kilometers per hour, and the train speed is 125 kilometers per hour. Okay, so then they say determine how long it would take to travel by train. And so we know that the time is equal to the distance over the r, and we know our distance is 1,500. Perfect. And so our time is 12 hours on a train. Okay? So I know that these are all the examples that are in the book, but we're going to do some more on our own. Okay, so if you flip to the blank pages at the end, these aren't. I said there's two types of questions, but in the book they only have one type of question. So we're going to show you the other kind. Okay, so if the blank pages, so these are called working together problems. I know, it's kind of a nice name, isn't it? Working together problems. Okay, so this is one pipe can fill a tank in 20 minutes, and another pipe can fill the same tank in 30 minutes. How fast could you fill one tank with both pipes? Okay. So if you think about this question, like Mr. Trimble was saying that this was actually taken off a grade 9 diploma, and the most common answer was 50 minutes for both pipes to fill it.
10 minutes. People add them. Find out. 20 plus 30, 25. They go 25 minutes. You don't even think about it. Actually, got slower. How it's one by itself. 25 and 50.
Mm-hmm.
You get 20 minutes. You got another pipe going. What?
Okay. So that's one thing about when we're working with these problems. Always look at your answers and think about what it's asking and ask yourself, does this actually make sense? Like on the previous question, one of our answers was a negative. We know that that doesn't even make sense. So if on a question like this, you would get 50 minutes or something, you know that there's something going on with your thinking because it should definitely take less time rather than more time. Usually travels out of value.